So now we're going to solve a problem with regards to the last topic, which is productivity. So let me read the problem to you. Connie Baker, president of Fleming Chemicals, has just concluded a meeting with two of her plant managers. She told each that their product was going to have a 50% increase in demand next year over the year's output, which is expected to be 10,000 gallons. A major foreign source would be available again, and the result was twofold. First, the price of the materials was expected to increase by 4 times. Second, many of the less efficient competitors would leave the business, creating more demand and higher output prices. In fact, output prices would be 2 times more. In discussing the situation with her plant managers, she reminded them that the automated process now allowed them to increase the productivity of the material. By using more machine hours, evaporation could be decreased significantly. This was a recent development and would be operational by the beginning of the new fiscal year. There were, however, only 2 other feasible settings beyond the current setting. The current usage of inputs for the 10,000 gallon output, which is the current setting, and the input usage for the 2 settings follow. The input usage for the remaining 2 setting is for an output of 15,000 gallons. Inputs are measured in gallons for the material and in machine hours for the equipment. So here are the input quantities. For the current settings, materials is 25,000 gallons, equipment or machine hours is 6,000. For setting A, the materials are 15,000 gallons and machine hours is 15,000. And for the setting B, materials is 30,000 gallons and machine hours is 7,500. The current prices for this year's inputs are $3 per gallon for materials and $12 per machine hour for the equipment. The materials price will change for next year as explained, but the 12,000 rate for machine hours will remain the same. The chemical is currently selling for $20 per gallon rather. Based on separate productivity analysis, one plant manager chose setting A and the other chose setting B. The manager who chose setting B justified his decision by noting that it was only setting that clearly signaled an increase in both partial measures of productivity. The other manager agreed that setting B was an improvement, but that setting A was even better. So the requirements are: number 1, calculate the partial measures of productivity for the current year and for the 2 settings. Which of the 2 settings signals an increase in productivity for both inputs? And number 2, calculate the profits that will be realized under each setting for the coming year, and which setting provides the greatest profit increase. And number 3, calculate the profit change for each setting attributable to productivity changes. Which setting offers the greatest productivity improvement? By how much? So let us solve this problem in Excel. As you can see here, I have already placed the necessary details in order for us to solve this problem. So now, let us answer the first requirement, which is calculate the partial measures of productivity for the current year and for the 2 settings, and which of the 2 settings signals an increase in productivity for both inputs. To compute for the partial measures of productivity, we will make use of the productivity measure, which is computed by outputs over inputs. So, for materials, is computed by, so for the current setting, in terms of materials, that is computed by 10,000 gallons which represents the current year demand, divided by its actual quantity in gallons, which is 35,000. And that would give us 0.40 productivity. And for its equipment, that is again 10,000 gallons, because that is the output, divided by its input, which is 6,000, and that would give us 1.67. And now for setting A, that is computed by 15,000 divided by its actual quantity, which is 15,000. So that would give us 1. And for equipment, that is again 15,000 divided by its input in machine hours, which is 15,000 as well. So that would give us 1. Now let's proceed into settings B. So in terms of material, that is computed by 15,000 gallons output divided by its input, which is 30,000. That would give us 0.50. And then for equipment, that is again 15,000 divided by 7,500 hours input. And that would give us 2. So that's how you compute for the first requirement. So which of the two settings signals an increase in productivity for both outputs? So clearly, looking at the table, better productivity is in setting B. Okay, now let's proceed on to the next requirement, which is to calculate the profit change for each setting attributable to the productivity changes. Calculate the profits that would be realized under each setting for the coming year. Which setting provides the greatest profit increase? So in here, we're just I already laid out the pro forma income statement. So for sales, that is for the sales of setting A, that is computed by multiplying the output prices, which it says here in the problem that the chemical is currently selling for 20,000 gallons, so that is our selling price, multiplied by 2, because it is said that output prices would be 2 times more, and then we're just going to multiply the product by the actual output, which is 15,000. That would give us 600,000. And now for the input costs, for materials, that is 4 times multiplied by 3, because again it is said in the problem that the price of the materials was expected to increase by 4 times, and the current price for this year's input 4 gallons is $3, and then we're going to multiply the product of that by 15,000 gallons. That would give us 180. And for equipment, we're going to multiply $12 per machine hours multiplied by 15,000 equipment hours. That would give us 180 as well. So the total input costs for setting A is 360,000, and the net profit is 600,000 sales less the input cost. That would give us 240. And now let's compute for the setting B. So for sales, again, that is 15,000. Let me correct the formula. 15,000 multiplied by the product of 2 times its selling price, which is $20, and that would give us 600,000 as well. And now let's compute for the input cost of setting B. So for materials, that is computed by, again, $3 per gallon multiplied by 4 times, or multiplied by 4, because it is said again in the problem, materials was expected to increase by 4 times. And we're going to multiply the product by 30,000 gallons. And that would give us 360,000. And for the equipment, we're going to multiply $12 per machine hour by 7,500 hours. That would give us 90,000. And the total input costs for setting B is 450,000. And the net profit is 600,000 less total input cost, and that is 150,000. So if we're going to look at the numbers, it is clearly that setting A is better in profitability. Okay, now let's proceed on to the last requirement, which is calculate the profit change for each setting attributable to productivity changes. Which setting offers the greatest productivity improvement, and by how much? So in here I have already again laid out the table for easy computation. So first we're going to place all of the actual quantity for the current settings, PQ, and setting A. Oh, and by the way, we're going to analyze first the changes in productivity for setting A. So for the current settings, that is 25,000 gallons. For setting A, that is 15,000. And now we're going to compute for PQ. So in here, we're going to get the output for the setting A divided by the productivity ratio of materials in the current setting, and that is 0.4. That would give us PQ quantity of 37,500. And we're going to input its cost. For the current setting, that is $3. And then for PQ, we're just going to divide the prices. So in this side, it's going to be the current year's cost, which is $3. And then for this side, that is $12, because 4 times 3. And then for setting A, that is 12 as well. So now we're going to compute the variances. So in here, we're going to deduct 37,500 less 25,000 gallons for the current year, and then multiplied by 3. You could use either because they're just the same. So yeah, that would give us 37,000 unfavorable. And this variance corresponds to growth pala. And then now we're going to compute for the variance that corresponds to price recovery. So in here, we're going to deduct $12 by 3 multiplied by the quantity for PQ, and that would give us 337,500 unfavorable. Now onto the last variance, which corresponds to productivity. So in here, we're just going to deduct 37,500 by 15,000 multiplied by its cost, which is $12. And that would give us, okay, I'm sorry, let me put this in here. And that would give us 270 favorable. And now let's proceed on to the second input, which is equipment. So again, we're going to place the actual quantity for each setting. So for the current setting, that is 6,000. For setting A, that is 15,000. And then for PQ, again, we're going to divide the output of setting A by the productivity ratio of the equipment in the current setting, which is 1.67, and that would give us 9,000. So for the costs, that is $12, because it is stated here in the problem that the current price for this year inputs for machine hours is, or for equipment rather, is $12 per machine hour. And then for PQ, we're just going to split the prices. So on this side, that is $12, and then for this side is $12 as well. And then this one is $12 also. Okay, so now let's proceed on to solving the variances, which corresponds to growth. So to solve that, we're just going to deduct 9,000 machine hours by 6,000 machine hours of the current setting multiplied by its cost, which is $12. Which would give us 36,000 unfavorable. And now for the variance that corresponds to price recovery, that is $12 less $12 for the setting A multiplied by the excuse me, multiplied by 9,000, which is the PQ quantity, and that is 0. And then lastly, for the variance that corresponds to productivity, we're going to deduct 15,000 machine hours of setting A by 9,000 machine hours in PQ multiplied by its cost, which is $12, and that would give us 72,000 unfavorable. There you go. And then now let's analyze the changes in productivity for setting B. So once again, for materials, we're just going to input the actual quantity. So for the current settings, again, that is 25,000 gallons. For setting B, that is 30,000 gallons. And for PQ, we're going to use outputs for the setting B, which is 15,000 gallons divided by the productivity ratio of materials in the current setting, which is 0.40, and that would give us 37,500 gallons. And now let's input the costs. So for the current settings, that is $3. For setting B, that is $3 multiplied by 4. Again, because it is stated that the price of material was expected to increase by 4 times. And then for the prices under PQ, we're just going to split it again. So for this side, that is 3, and then for this this side is 12. So now let's solve for the variance that corresponds to growth. That is computed by 37,500 gallons under PQ less 25,000 gallons under the current settings multiplied by its cost, which is 3, and that would give us 37,500 unfavorable. And then for the variance that corresponds to price recovery, is going to get the difference between $12 and $3 multiplied by the quantity or PQ quantity, and that would give us 337,500. Again, this is unfavorable. And then for the last variance, which corresponds to productivity, this is computed by deducting 37,500 gallons by 30,000 gallons in setting B multiplied by its cost, which is 12, and that would give us 90,000 favorable. Okay, now let's proceed on to the second input, which is equipment. Again, let's input all of the actual quantity for each setting. So for the current setting, that is 6,000. For setting B, that is 7,500. And for PQ, again, we're going to use setting B's output divided by the productivity ratio of equipment under the current setting, which is 1.67, and that would give us 9,000 machine hours. And let's input the costs. So for current settings, that is $12. And then for setting B, that is $12 as well, because there's no change whatsoever. And then we're going to split the costs under PQ. There you go. And then now we're going to solve for the variance, which corresponds to growth, and that is computed by 9,000 less 6,000 multiplied by the cost, which is 12, and that would give us 36,000 unfavorable. And now for the variance that corresponds to price recovery, that is $12 less $12 as well, multiplied by 9,000 quantity under PQ, that would give us 0. And then lastly, the variance that corresponds to productivity, which is computed by 9,000 less 7,500 multiplied by the cost, which is $12, and that would give us 18,000 favorable. Now we're going to analyze the variance for sales. So the current sales for the current settings, that is 10,000 gallons. And then for next year's sales, that is 15,000 gallons. And PQ, that is 15,000 gallons. We're just going to make use of the output for the next year, which is 15,000. And the sales price for the current settings, that is $20 per gallon. For the next year's sales, that is $20 per gallon multiplied by 2. Because it is said in the problem that output prices for next year would be 2 times more. So that is 40. And then for PQ, we're just going to again split the prices. So on this side, that corresponds to the current sales price, and for this side corresponds to the next year sales price. So 40. Now let's compute for the variances. So for the variance that corresponds to growth, that is computed by again 15,000 less 10,000 multiplied by its price, and that would give us 100,000 favorable. And then for the variance that corresponds to price recovery, that is computed by again $40 less 20 multiplied by the quantity under PQ, which is 15,000, and that would give us 300,000 favorable. And then lastly, for the variance that corresponds to productivity, that is computed by 40 less 40 multiplied by 15,000, that would give us 0. This is always 0. So there you go. Oops. Let me erase this one. Okay, now so let's put here all of the variances that we've computed for setting A. So for sales under the growth, in the growth column, we're going to put the growth variance, the variance that corresponds to growth, and that is 100. For price recovery, that is 300. For productivity, well, that is 0. So the total, okay, let's just put 0. So for the total variance for sales, that is 100,000 favorable plus 300,000 favorable. That would give us 400,000 favorable. And then for inputs, so for materials under growth, that is 37,500 unfavorable. Under price recovery, that is 337,500 unfavorable. And for productivity, that is 270,000 favorable. And that would give us a total of 105,000 unfavorable. And then for equipment, the variance under the growth column, that is, where is it? Here, 36,000 unfavorable. Under price recovery, that is 0. Oh, let me put 0 here for the formula. And for productivity, that is 72,000 unfavorable, and that would give us 108,000 unfavorable. Let's get the total of the variances for the inputs. And there you go. And then the net effect under growth, that is 26,500. Under price recovery, that is negative 37,500. And for productivity, that is, oops, wait, this is wrong. This should be there. Negative 198,000, and the total net effect is 400 less 213, that is 187,000. And now for setting B rather. So for sales under the growth variance, that is under the growth variance, that is 100 favorable. Under price recovery, that is 300 favorable. And then again for productivity variance, that is 0. So that is a total of 400,000 favorable. And now for materials under the growth variance, that is 37,500 unfavorable. Under the price recovery, that is 37,500 unfavorable. And then for the productivity variance, that is 90,000 favorable, which would give us a total of 285,000 unfavorable. Now, for equipment, under the growth variance, that is 36,000 unfavorable. For the price variance, that is 0. Wait, let me put 0 here. That, and then for the productivity variance, that is 18,000 favorable. That would give us 18,000. So let me just get the total of these variances for inputs. Okay. Now let's compute for the net effect. Under the growth variance, that is 100,000 less 73,500, and that would give us 26,500 net effect. And under the price recovery variance, that is 300,000 less 337,500, and that would give us negative 37,500. And under the productivity variance, that is 0 less 108, that is negative 108,000, and that would give us a total of this one, 97,000 variance, net effect rather. So answering the question, which settings offer the greatest productivity improvement and by how much, it is clear that setting A has a better productivity improvement by, is computed by 187,000 net effect for setting A less than 97,000 net effect for setting B, and that is 90,000. So that is for this problem.